Hey all, today we are talking about empirical formulas. So if you remember, I told you in class, pretty much from now on, whenever you see something in grams, you should just immediately convert that to moles. We're pretty much not working in grams ever again. Convert it to moles. So that's my first step here. I've got a formula that contains 4.20 grams of nitrogen and 12.0 grams of oxygen. I'm converting those to moles. So I got 4.20 grams of nitrogen. Label, label, label. Cannot emphasize this enough. Label. I've got two things going on here. I've got nitrogen going on. I've got oxygen going on. Label them so you can keep them straight. All right. Over X moles. We've done this in class. So I'm not going to spend a lot of time on how we're converting to moles because we've done this a bunch of times. Get my molar mass from the periodic table. And there we go. And I'm going to do quick algebra until I get to 3 sig fig 0. It comes out to 0.29987. So that actually is going to round to 0.300 moles of nitrogen. And then for my oxygen, I've got 12.0 grams of oxygen. X moles, 15.999 grams for every 1 mole. Again, some quick algebra here. It's going to come out to 0.750 moles of oxygen. Okay. So then, once I've got my moles of each, and you might have 3 or 4 different elements, it doesn't matter, get the moles of everything. When you got the moles of everything, we need to ratio them, which means we're just going to divide them all by the smallest. So I want to find the ratio. I'm going to divide them by the smallest. So between these two, the smallest is the nitrogen. So I'm going to divide this by 0.300. I'm going to divide this by 0.300. This is obviously going to be 1. So in my formula, I'm going to have 1n for every 0.75 divided by 0.3, 2.5 O's. And this works out great to show that sometimes we get a decimal. Don't round that up to a whole number. 0.5, that's a decimal we know. Another ones you might see are 0.33, that's 1/3, 0.67, that's 2/3, 0.25 is 1/4, 0.34 is 3/4, sorry, 0.75 is 3/4. So when you see a decimal that's not like 0.9 or 0.01, don't round it. Sometimes you do get like 0.98, round that. That's really close to a whole number. Sometimes you get, 0.015, great, round that down. Those are really close to the whole number. But 2.5, that's not close to the whole number. That's a very solid fraction. So we need to clear the fraction. So I say, okay, what can I multiply this by to clear that fraction? Well, it's 2.5, so 2 1/2. So I can multiply that by 2. So I'm going to do times 2 times 2, because what you do to one thing, we have to do to both. We want to keep the ratio the same. So that ends up being 2n. So I multiply these both by 2. Now I've got 2 n's and I've got 5 O's. Now 5 is a much better number. That's a whole number. We can't have fractions of an atom. So that makes way more sense. So the last step is just to write the formula. So I'm just going to write that up here. So I have 2n, so I'm going to write N2O5. That is my final formula, the empirical formula. Remember, empirical formula means the simplest formula. So it's the simplest formula. It's not always the formula that the molecule actually is, because sometimes molecules exist in not simplest form, but it is the simplest form of the combination of atoms. So just to recap what we did here, our steps. First things first, convert to moles. You have grams, convert them to moles. Once you've got everything in moles, divide everything by your smallest number of moles. So even if you have 3 or 4 elements, you're still dividing them all by the same number. Divide everything by the smallest number of moles. So you're always dividing by the same number because you're trying to figure out that ratio. So for every 1 nitrogen, there's 2.5 oxygens. But if you run into a case like this, where there's a fraction like 2.5 or 1.5 or 2.67, that's a 2/3 fraction, you need to clear the fraction. Remember, you can clear the fraction by multiplying by the denominator. So this fraction is 1/2. I can clear that by multiplying by 2. If you came across 0.3 or 0.67, those are thirds, you can clear that by multiplying by 3. If you come across a fourth, you can clear that by multiplying by 4. And you do that to everything. What you do to one thing, you have to do to them all. So clear the fraction, and then you just write your formula. And that's it, empirical formulas.